Welcome back. This is video 2 of Chapter 12 for AP Statistics. Simple random sampling is great, and like I said, it's the standard, but it's not the only fair way to sample. More complicated designs sometimes actually save money and help avoid some sampling problems. And the one thing you have to keep in mind is that randomness must be used at some level. At some point, chance has to come into play. One such method is stratified random sampling. The population is sliced into a homogeneous group called strata based on a critical characteristic that you think will affect the responses to the survey. An SRS is conducted within each stratum. So each of all the strata will get their own simple random sample, and then the results are combined to make your final sample. This is a common sampling design. So what's the major benefit of it? If it's so common, it reduces the variability of our samples and thus our results. Okay. Otherwise, let's say I was going to sample all the students at Houston Christian. I was going to take, I don't know, a sample of 60 students. It could be that all 60 students end up being freshmen. Well, then the sophomores, juniors, and seniors are all left out. So what I might do instead is use grade level for my strata if I thought that was critical on student opinions about something. And what I would do then is randomly select 15 seniors, 15 juniors, 15 sophomores, 15 freshmen, and then combine those together to make my one big sample. That reduces the variability of the samples because I'm guaranteed to have 15 of each grade level. Okay? Whereas before, if I just do a simple random sample, I could end up with I used an extreme example, 60 freshmen and none of anybody else. I could end up with 50 seniors and 10 juniors. That would be equally likely as a group that had 15 of each grade level. Okay, because remember, every group of the same size is equally likely. So here, people could argue really well that stratified sampling might actually be better because it gives a better representation based on that critical characteristic, in our case, grade level, that can reduce bias. And it can also help us notice important differences among groups. So if seniors had a different opinion about something than freshmen, it would be good if we were able to determine that. Okay, another example of a sampling method is cluster sampling. Here you split the population into similar parts or clusters. And you select one or a few clusters at random and perform a census within each one of them. Each cluster must be representative of the whole population to ensure an unbiased sample. The biggest benefit here is that it's more practical than a simple random sample. Cluster sampling is not the same as stratified sampling, and it's really important that you get the two differentiated in your minds. We stratify to ensure that our sample represents different groups in the population and sample randomly within each stratum. Strata are internally homogeneous but differ from one another. Clusters are more or less alike, and they are internally heterogeneous and each resembling the overall population. We select clusters to make sampling more practical or affordable. Multistage samples are sampling schemes that combine several methods. Professionals usually use some combination of stratified and cluster sampling as well as simple random sampling altogether. Systematic samples, you have to randomly select a starting point, that's where the randomization comes in a list or in a group of individuals, then choose every case, say every 10th individual to be in the sample. So you might take an alphabetical list, roll a die to know where to start. And so if the die shows 4 little dots, they're actually called pips. 4 little pips are showing. You'd start with the 4th individual and then include every 10th individual. And you do have to justify the use of random systematic sampling because it has to be that there's no reason to believe that the order of the list could be associated in any way with the responses sought. Okay, so if you let's say you were interested in quality control in, say, a nursing home, and let's say all the sheets were changed on Sunday. Okay, well, if you drew out of a hat and you drew that Sunday was going to be the day that you showed up and you went every 7th day, then you would always be there when everything looked nice and clean as far as the sheets go. It could be that Sunday is the only day they changed the sheets, and if you'd gone there on Saturday, you would have been horrified. But because you went on Sunday, you weren't horrified. All the sheets were clean. That's not because they were kept perpetually clean. It's just that that's the day they happen to do it. So you really want to make sure that there's no reason to believe that the order of the list would be associated with anything that might affect the responses. One benefit of doing a systematic random sample is that it's more practical than a simple random sample. It's just easier to conduct. Okay, so here's an example where you're going to pick out, or you're going to determine what kind of sample was taken. At Sumville High School, the administration wants to determine the student body's opinion about block scheduling. Determine the type of sampling being used in each of the following designs. The first design says select 5 of the 25 randomly assigned homeroom classes and conduct a census of each. Okay, so each homeroom is like a little random sample because students are randomly assigned to it. So each homeroom should be a representative sample of the whole student body. And we're going to select 5 of them, and we're going to conduct a census within it. Well, this sounds like a cluster, because remember, clusters are little random samples of the entire population. You select a few, and you do a census. So number 1 should be cluster sample. Obtain a list of freshmen, sophomores, juniors, and seniors. Randomly select 50 students from each class, combine to make your final sample. That sounds very familiar to what I spoke of earlier. Freshmen are homogeneous according to grade levels. Sophomores are homogeneous in reference to grade levels, so are juniors and seniors. So we've got groups that are alike within the group and different from each other. So those are strata. And so this would be stratified sample. Obtain an alphabetized list of all students. Roll a die to determine a starting place. Choose the student corresponding to that number and every 10th student from that point on. Well, that sounds systematic, and sure enough, it is a systematic sample. Now, one thing we have to be careful with is defining the who. The who of a survey can refer to different groups, and the resulting ambiguity can tell you a lot about the success of a study. First of all, there's the population. That's what we really want to know something about. But remember, doing a census is just too expensive, too hard, too almost impossible to do in many cases. So we want to take a sample from our population. But sometimes it's really hard to get a list of the exact population. Let's say we talked about we want to do a sample of U.S. Voters, okay, or U.S. citizens who are old enough to vote, 18 and older. Well, we don't have a list necessarily available to us of U.S. citizens 18 and older. So what we have to use for a sampling frame, we have to use maybe voter registration rolls. So we use the voter registration rolls. Well, there's some citizens who aren't registered to vote. They want to be, off the grid. They're not registered to vote. So this sampling frame is just an approximation of the population. It may be the best that we can do. So we randomly select, say, 500 people from all the voter registration rolls across the U.S. So there's 500 people. Some people aren't going to answer. Okay, that's called non-response, and it happens. So let's say we only get 300 people who respond. That's our actual sample. The question is, are the 300 people who we actually sample representative back to the population? Is there some difference between the people who did not respond who are in our target sample and the people who actually respond? Is there a difference between the population of all U.S. citizens 18 and older versus the sampling frame of voter registration rosters? Every step along the way, we have to ask that question about representativeness. Okay? The best thing about simple random sample is it retains the who. Okay? It retains the who all the way through, and that's not necessarily true for other methods. The survey itself must be valid. That's another critical issue. It must yield the information we are seeking about the population we are interested in. Before you set out to survey, you need to ask yourself, what do I want to know? Am I asking the right respondents? Okay, it's even my population that I'm trying to find out about. Is that the right population? Is my sampling method going to give me a representative sample? Am I asking the right questions? What would I do with the answers if I had them? Would they address the things I want to know? These questions may sound obvious, but there are a number of pitfalls to avoid. You need to know what you want to know. You got to use the right frame, the right sampling frame, and you need to tune your instrument. You need to cull through your survey and just get it down to very specific questions that ask exactly what you want to know, because if it's too long, more people are going to refuse to answer it, especially answer it completely. So again, ask specific rather than general questions. Ask for quantitative results when possible. Be careful in phrasing questions and be careful in phrasing answers. Try not to leave things open-ended. Try to give people answer choices. It's much easier to code answer choice. You know, when you're given A, B, C, D, much easier to measure the results than trying to interpret what people answered and classify them and then do statistical analysis on it. The best way to protect a survey from unanticipated measurement errors is to perform a pilot survey, a trial run of a survey you eventually plan to give to a larger group. Okay, so you give it to just maybe, a small number of people from the same sampling frame and see how it goes and see what kind of information you get back and see if you need to tweak your survey at all. Okay, so what can go wrong or how to sample badly? First thing is using volunteers. A voluntary response sample is just basically when you just put it out there, make a big, huge group appeal. Could be on television, could be on radio, could be through the internet, could be in the newspaper. You just pose a question and ask people to respond. These are biased toward those with strong, usually negative opinions or people who are extremely highly motivated, because people who feel kind of whatever about an issue aren't going to be motivated enough to participate. Okay, so the results are usually useless for inference. It's not a larger population that the sample represents. Convenient sampling, it includes the individuals who are convenient, the people you know who are right by you. It may not be representative of a larger population, so there's really no point in doing it. Sampling from a bad sampling frame. A simple random sample from an incomplete sampling frame introduces bias because the individuals included may differ from the ones not in the frame. This leads to undercoverage of the groups left out of the sampling frame. So, for instance, if somebody wanted to find out what voters in a certain district felt about red light cameras, for instance, and they did a simple random sample using the voter registration rolls, that's absolutely reasonable, and then they called each person. Well, there you're leaving out people who don't have phones or people who don't answer their phones to numbers they don't know. And if their opinion about the red light cameras differ from everybody else's, then you're going to have a biased sample. So what else can go wrong? Watch out for non-respondents. That can lead to non-response bias. Even with the simple random sample, you retain that who, everything should be representative. But man, if the people who just flat refuse to respond have a different opinion on something than the people who do respond, you could run into problems with having biased results. No survey succeeds in getting responses from everyone. Like I said, the problem is that if those who don't respond don't have the same opinion as those who do. So the problem is that those who don't respond may differ from those who do. And so your results aren't going to take their opinion into account. Don't bore respondents with surveys that go on and on and on and on. Sometimes people think, hey, well, while I've got their attention, I'm going to find out this information and that information. Surveys that are too long are more likely to be refused, reducing the response rate and biasing all the results. And so you've just wasted your time. So that is not something you want to do. Work hard to avoid influencing responses. Response bias refers to anything in the survey design that influences the responses. If a man with a mustache comes up and asks you questions for a survey and then he asks you if you trust people with mustaches, well, you're going to, even if you don't, you're not going to say no because there's a guy there with a mustache asking you that. You may not say no then. Whether, that's an outright lie, which hopefully you wouldn't do, or if you're like, well, this guy's nice and he's got a mustache, so I'm going to just say no. You just got to be careful with those things. The wording of a question can influence the responses. Consider these two. Asking essentially the same thing, but they have leading sentences that tend to prime one result or the other. Sugary drinks contain hundreds of empty calories. Obesity runs rampant in the United States. Should people be allowed to buy supersized sodas? Well, you might be tempted to say, well, no. But listen to this question. America has been built on a long tradition of personal liberty. Should people be allowed to buy whatever size soda they want? Yes, they should. I mean, this is America. We should be able to buy whatever soda we want. Can you see how the phrasing of each question kind of leads people to one answer or the other? You have to avoid that. Okay, you don't want to bias your results. You want to be honest. Look for biases in any survey you encounter before you collect the data. There's no way to recover from a biased sample of a survey that asks biased questions. There's just nothing you can do. Spend your time and resources reducing biases. If possible, do a pilot test of your survey just so you can see what the data look like and then try to analyze it and see if it's giving you the information you want. And always report your sampling methods in detail so that other people who read your report and look at your data have an idea of how the data were collected. It's just part of intellectual honesty. Okay, guys, that's it for Chapter 12. Do the problems that I've suggested that you learn, and I will see you in class next time. Have a good day.